Today we are going to discuss about question number 4, exercise 11.2, surface area and volume. What about this question? The radius of a spherical balloon increases from 7 centimeter to 14 centimeter. What? The radius of a spherical balloon. What about the balloon? Spherical. And its radius, initial radius of balloon is what? 7 centimeter. And balloon is in a shape of spherical, sphere shape. Its radius is increased from 7 centimeter, initially 7 centimeter. After increasing its radius of balloon after increasing is what? 14 centimeter. Initially balloon radius is 7 centimeter. After increasing it is what? 14 centimeter. How it is increasing? Once we pumped into it. Once we pumped air into it. Observe what is happening in this question. We are having balloon and that one is what? Spherical shape, sphere shape. Initially radius is 7 centimeter. Once we pumped air, then its radius is increased to 40 centimeter. It means we are having two radius. One is initial radius is 7 centimeter. So, and once we pumped air, then radius of spherical balloon is increased to 40 centimeter. Find the ratio of surface area of a balloon in these two cases. Clear? Initially surface area of a balloon, and once we pumped air, then surface area of a balloon. Both ratios we want. Clear? So how we will solve? Observe simple question. How we will proceed? What about its solution? Let initial radius R1 equal to 7 centimeter. Initially, without pumped air, initially we are having 7 centimeter radius spherical balloon. Initial radius R1 equal to 7 centimeter. Now we are pumped air, then radius is increased to 14 centimeter. After increasing radius R2. Once we pumped air, then shape of spherical balloon is increased. After increasing radius R2 equal to what? 14 centimeter. Two things we are having. Initially we are having balloon, spherical balloon, radius is what? 7 centimeter. Once we air pumped, then radius is increased to 14 centimeter. We require the surface area of these two spherical balloons ratio. So surface area for initial balloon. What? Surface area for initial balloon is what? A surface area of a sphere. Balloon is in a shape of sphere. So surface area of a sphere is what? 4 pi r square, but initially we are having radius r1 square. Clear? This one is what? Surface area of initial balloon. Surface area for increasing balloon equal to, after air pumped, radius is increased to 14 centimeter, and that one is what? R2 radius. So surface area for increasing balloon is what? 4 pi r2 square. Clear? Required ratio, we want what? Ratio of surface areas of the balloon in these two cases. So required ratio equal to, I am considering surface area of initial balloon is A1. This is A1. This is A1, and this one is what? A2. I am considering this one as a A2. Observe, surface area of initial balloon A1 is what? 4 pi r1 square. Surface area for increasing balloon is A2, and this one is what? 4 pi r2 square. So required ratio A1 upon A2 will be what? A1 is what? 4 pi r1 square divided of 4 pi r2 square. Clear? 4 pi to 4 pi will be cancelled. We are getting r1 square by r2 square. R1 is what? 7 centimeter. So we can say 7 into 7 divided of R2 is what? 14 into 14. Solve these. How we will solve? 7 1 ja 7, 7 2 ja 14, 7 1 ja 7, 7 2 ja 40. We are getting 1 by 2 2 ja 4, 1 by 4. So required ratio is what? 1:4. 1:4 is what required ratio. Simple question, not hard. This is the required ratio. 1:4. 1/4 is required ratio of surface area of the balloons. Clear? Observe again what we are doing in this question. The radius of a spherical balloon increases from 7 centimeter. Initially we are having balloon and radius of that balloon is what? 7 centimeter. Now we are pumping air, then radius is increased due to same balloon is what? 14 centimeter. Initially 7 centimeter and balloon is in the shape of sphere. So surface area of an initial balloon, once radius is what? Initial phase 7 centimeter. That time initial balloon surface area and balloon is in a shape of sphere. So area will be 4 pi r1 square. Clear? We are considering r1 as a initial radius. That time it is what? 7 centimeter. Once we pumped air and radius is increased R2, that one is what? 14 centimeter. That time area A2 is what? 4 pi R2 square. We require what? Ratio. So required ratio of surface areas A1 upon A2 will be what? 4 pi R1 square upon 4 pi R2 square. R1 is the initial radius and R2 is what? Once we pumped air, that time radius R2 is what? 14 centimeter. So we are putting R1 R2 and solving, we are getting the required ratio 1:4. That one is the answer. I hope you understand this question. That's all about this question. Thank you so much.